My name is Asia Faraci, and today I will be presenting on what is sense making and how it works. First, we will discuss what sense making is. The picture in the upper right corner is the logo for the National Science Teaching Association, NSTA for short. The NSTA defines sense making as actively trying to figure out how the world works or how to design solutions to problems. In other words, using critical thinking skills to get a deeper understanding of science and solve problems or answer questions. The picture in the bottom left corner are the four components of sense making: phenomena, student ideas, science ideas, and practices, which we will discuss in further detail in the following slides. All these components allow for students to further discuss their ideas and collaborate. The image that I included in the bottom right corner symbolizes how collaboration can help detangle ideas and make the picture a little bit more clear. Now we will discuss the components of phenomena in science ideas. Phenomena refers to the observation of natural happenings in our world that we can explain and predict using science. Looking at the image in the top left corner, there is a boy observing the grass and plants with a magnifying glass. The picture in the bottom left corner is another example of observing phenomena as the child is looking towards the sky, most likely at the sun or the clouds. Moving our focus to the middle photo, we will now discuss science ideas, also known as DCIs or disciplinary core ideas. Disciplinary core ideas are used to help students understand the underlying scientific concepts related to the phenomena they observed. They act as the big idea or the main idea. For example, if we use the photo of the boy observing the grass, we could then link this to a DCI involving life science, specifically zooming in on organisms or ecosystems. The next slide discusses the components of student ideas and practices. Student ideas are the portion of sense making where students discuss the how and the why of the phenomena they observed by collaborating with others around them, as shown in the image in the top right. Students will typically do this by calling on prior knowledge and experiences and seeing what each individual knows or thinks and what they can put together to form stronger inquiries. When students are calling upon prior knowledge, you may hear things such as I remember or this reminds me of, as shown in the activating prior knowledge chart. This just lets you know that their minds are actively working. The last component of sense making is practices. Practices refers to direct involvement of the phenomena, which is typically a hands on experiment. Completing hands on experiments allows for students to see the behind the scenes and really reach that aha moment. The photo in the top right corner shows a group of young students completing a hands on experiment. In this case, the students are experimenting with liquids or other matter. You can see the expressions on their faces, insinuating excitement and curiosity. This correlates with the image diagonal from it, showing a light bulb drawn on the chalkboard, showing that aha moment. The purpose of completing hands on practices is to investigate and find out for yourself. To show how all these components of sense making work together, I will explain how we could use this process in a real life experiment. First, starting with the photo in the top right, this image shows a man watching the rain from the window. This will be our phenomena. Rain is a natural occurrence which is being observed by the person. To connect this phenomena to science, we will use the science ideas, also known as the disciplinary core ideas. Following the arrows to the second image, we will now relate this phenomena to a DCI of Earth space science, specifically weather and climate. We will now use this DCI as the focus of our lesson or unit topic. With the focus on the DCI, students can now move on to the next step, which is student ideas and collaboration, as shown in the next image, again following the arrows. Students will begin collaboration and pulling prior knowledge regarding what they know about rain and the water cycle. This will help with their overall understanding. Moving on to the last image, students will conduct an experiment based off the picture of the water cycle, and their experiment will then look like something of the middle photo as the arrows follow. Students will recreate this water cycle in a bag or a bottle. Either works. Students will draw in their object like the drawings and labels in the image. Water at the bottom, sun at the top, etc. After drawings are complete, students will place their bag or bottle by the window for a heat source. Throughout the day or days, the cycle will begin and students will notice first evaporation. The heat source will cause the water to evaporate. After water begins to evaporate, the water vapor will begin to collect on the inside of the bag at the top to show condensation, equivalent to how clouds form and collects rain. The water droplets will eventually get larger and begin to fall back down, equivalent to rain falling, which is precipitation. Lastly, students will see the water collecting again at the bottom of their bag or bottle, just like how bodies of water collect the rain that was once taken from that same body of water or other water sources. This is the collection stage, the final stage. Students will have to check in on their project frequently to watch for changes. The drawings on the bottle or bag are there to make the changes clearer and really show how it works in the outside world. After completing all these steps, students will have a better understanding of why and how it rains, which is the overall goal. Overall, sense making is used to help students better understand science phenomena. As an educator, we can promote proper sense making by asking productive questions, conducting meaningful experiments, and checking in with our students to check for understanding and comprehension, and also allowing them to use their critical thinking skills and figure out things for themselves. When using all four components, students will always be set up for success in the science world. Collaboration and hands on learning can take your students very far, especially when pairing that with disciplinary core ideas and giving them something to focus on. Finding that light bulb moment can sometimes be difficult for students. Using the sense making framework will help guide them and prepare them for understanding future phenomena. Thank you.